Namaste students, myself Sunil Kumar from the Department of Computer Science. Today we are moving to the third session based on the chapter that you can see here, problem solving methodology. Now first we will see is a very important chapter, that is problem solving methodology. We already discussed it in two sessions. Here is the third session. In this we are mainly going to discuss about the algorithm analysis, how we can analyze the algorithm, and also with the stepwise refinement process. So before moving to today's topic, in the last topic we discussed about what is algorithm mainly. What we discussed? What is algorithm? What is algorithm? Algorithm is a step-by-step finite sequence of instructions to solve a problem. If you want, any problem is given. For example, one problem is given for you or any task. If you go for IT company, you will be getting one task. If you got any task, then how we can solve a particular task? That if you want to solve any particular task or particular problem, then we have to apply some rules and some steps you have to go through. You have to go through with some steps for certain steps. Actually, that steps you should write down. That steps are actually known as algorithm. Then, if you want to create a software, whenever you are going to create software, certain steps are there to reach the output. After input, from the input, if you want to get the output, then certain steps will be there. That certain steps you can write in a chart or whatever it is, that is actually known as algorithm. It's a step-by-step process of solving the problem. Whenever a problem is given means that problem can be solved by step-by-step process. That step-by-step process is actually known as algorithm. After algorithm, then what we discussed about the characteristics of algorithm. That is very important. From that, you will get the 5 mark question. That is characteristics of algorithm. If you take the algorithm, there are different characteristics are there. Different characteristics are, one is input. If you take the algorithm, that should take one or more input and one more is output. The algorithm should produce output. So input and output is a mainly two characteristics. Other than that, next one is definite. Means if you take any step, that each step should perform at least one task. Without simply don't write any steps, that is a algorithm definite. All the steps should define some task. The next one is effective. Effective means if you are writing entire algorithm, the entire algorithm should work based on some principle. Entire algorithm should work based on the particular principles. That's why that is effective. It should be effective, and also terminate. That is important. If you take any algorithm, it's a finite number of steps. Actually, the algorithm means it's a finite number of steps. If you are writing algorithm, that should terminate, that should finish within a certain step. For example, some cases maybe 10 steps will be there, or some other cases it can take 100 steps like that. So after certain step, the algorithm should finish. That is different characteristics. After that, we discuss with the two algorithm. One is adding to a number. Whenever two numbers are there, means how to add. That also we discussed. When you are going to create algorithm, when you are going to develop algorithm, the first step is always start and last step will be the end. The first step is start step and last step will be the end step. The two steps are always required. Our first start and last step, and between that one we are writing the algorithm process or process of the program. For example, if you are adding two number means first you have to input two number, then you have to add two number. Then after that you have to show the result. So there are 3 steps will be there. Then after that we discuss with the one more algorithm, find the area of rectangle. Whenever rectangle is given means, then how you can find the area of the particular rectangle, that also we discussed in the previous session. So based on that I gave some worksheet. In that I have given find the area of pi r square, or means area of a circle, and also area of the some other shapes. So means triangle, that also finished. So that all these algorithm finished. Then whenever algorithm is given means it is possible to analyze the algorithm. Means if you want to reach particular solution, if you want to reach a solution from one step from the solution, there are different ways are there, or there are different algorithm possible. See here, there are maybe more than one approach. There are maybe more than one approach to reach or to solve a problem. Whenever any problem is given, means that problem can be solved by different methods. One person can use his own techniques and one more person can use its own technique. By using different techniques, it is possible to solve the algorithm, or possible to solve the problem. So for example, if you are here and you should reach one place, if you are from here and you should reach one place, if you want to reach a particular place, there are different ways will be there, different route will be there. We can go in one more way, or we can go in another way. There are two different, more than two different ways are possible to reach the particular destination. Destination is your destination. For example, if you want to travel here to Delhi, an example you can take. If you want to reach Delhi from here, there are different ways are possible. There are different routes are there. So which route we will select? That is actually known as analysis of algorithm. Which route we will select? Because if you want to reach here to Delhi, easiest or fastest way will select the fastest way, and we should reach early and safely. So like that, different options will be there. So based on our own conditions, we are going to reach our destination. So select the particular destination or select the particular route to reach the destination. That is actually there are different ways are there. So that different ways will be there. If you take the problem also to reach the particular solution. That is one example I give. To travel. So that is one example. But here in case of algorithm, there are different algorithms are possible to solve one problem. One problem is given means there are different ways will be there. There are different ways. Simple algorithm will get only one way. But if you go for complex big algorithms and all, or big problem you got, there are more than one or more than many approaches are there. More than one approach or many approaches will be available to reach the particular solution. The approaches are known as algorithm. Means more than one algorithm will be available. In that available algorithm, choice of particular algorithm depends on the performance analysis and also the measurements. There are different measurements are available and also performance analysis. There are based on this we can select the best algorithm which is suitable for the particular program. It is not possible to select all the algorithm for particular problem. Based on the measurements and based on the performance analysis, we can choose our algorithm. One algorithm is not possible to suit for, we will get the output actually. If you use the algorithm, we will get the output. That is not issue in that. But whenever we are going to select the algorithm, we have to select the best algorithm for us, which is suitable for particular environment or particular condition. Particular conditions of algorithms are not applicable. Some conditions of algorithm is very helpful. That algorithm we should select. And if you are going to select the particular algorithm, there are two algorithms. For example, algorithm 1, algorithm 2 algorithms are there. There are two ways are there, two approaches are there. Means, so we have to select which one is better. So based on performance analysis and also the measurements. The measurements are, if you are taking algorithm, the mainly two measurements are available. The first one is space complexity, second one is time complexity. There are mainly two measurements. If you take the algorithm, there are mainly two measurements that are available. The first one is space complexity, second one is the time complexity. What is the space and time? Time or space, there are mainly two measurements. I told here one is performance analysis is there, and also second choice is measurement. Based on these two, means based on this one and one more concept, then you can select the suitable algorithm for the particular problem. So first one is measurements. There are different measurements. One is space complexity, one more is time complexity. What is the space complexity and what is time complexity? Space complexity means an algorithm, how much space it uses. For example, if you want to develop an algorithm and if you are going to execute that one normally, if you develop the algorithm, after that algorithm, we are going to convert that into using the coding, programming language. By using the programming language, we will convert that into programs. And after program, then we are going to execute. When you are going to execute any program or a problem or an algorithm, simply you can take the algorithm. Algorithm is not possible to directly execute. Remember that one. Algorithm is not possible to execute directly. First, algorithm is that algorithm we should convert into programs based on the programming language. There are different programming languages are available. By using that programming language, it is possible to convert into programs. That program we are going to execute and we will get the output. Right? That is the steps actually. But here normally here we can take if you are going to execute an algorithm, just we can take like that. When you are going to execute an algorithm, what is the total space is required? What is the total space is required to execute particular problem or program, or you can say algorithm. That is actually known as space complexity. The total space is required to save and execute the algorithm. The total space required to save and execute the algorithm. That is actually known as space complexity. Space complexity means what? It's a total space required to execute and save. Mainly to save and execute, what's the total memory space is required? That memory space is actually known as space complexity. Okay, that is a space, total space. And also next one is a time complexity. The time complexity means it is a total time required to execute. Algorithm is not possible to execute. Remember that one? Algorithm is not possible to execute, but you can take algorithm because after algorithm you have to convert that into coding. That coding will be executed normally. So normally if you take algorithm only, if you are to writing algorithm, what is the total time required to execute the particular algorithm? Algorithm, for example, software. So normally in some cases, if you download any apps from internet, some app will take the more time to open. Some apps will take more time to open. Some app will take the less time to open. You can see that one. Same mobile only or same smartphone only, we can use. We can feel that one. So some softwares that uses more time to execute. Some will be using less time to execute. So that is actually known as time complexity. Total time required to execute particular algorithm. Total time required to execute particular algorithm, that is known as time complexity. Total space is required to save execute the algorithm, that is known as space complexity. Total space required to execute algorithm, that is known as space complexity. Total time required to execute algorithm is known as time complexity. That is the two measurements. Based on that one, you can say that which is the algorithm based on. So that is two measurements. One is space complexity, one more is time complexity. So here next one. Next one is analysis of algorithm. If you go to see the analysis of algorithm, we can analyze the algorithm. We will get the three cases. After analyzing the algorithm, we will get the three cases. First is a best case, average case, and last is a worst case. There are mainly three cases available after executing the algorithm. So we can say one is a best case, second one is average case, and finally worst case. There are different cases are there. So based on this one, we are going to check that one. Or which is the best case? How we can say which one is the best case? Which one? How we can say which one is the worst case? How we can say which one is average case? One example we can take. This is the numbers. This is here. There are different numbers are there. 1, 2, 3, 4 and 5. There are 5 numbers are available. For example, just 5 numbers are available. We have to search whether the 5 is there in a list or not. How you can check whether the 5? The first 5 will be taken. It is compared with the first element, first value. Whether 5 is equal to 1, so it's not okay. We'll go for next element. 5 is equal to 2, no. Next we'll go for next one. 5 is equal to 3, no. Like that you have to search with each element. So you should compare with each element. The first 5 is compared with 1, next 5 is compared to 2, 5 is compared with 3, 5 is compared with the 4, and 5 is compared with the 5. So like that you can compare the data. So like you can compare the data. Whenever in first total, what is the total number of comparisons required? 1, 2, 3, 4, 5 times you compare normally. Whenever the element is 1, whenever element you have to search 1. So only once you should compare. Only once you should compare. Remaining time is not required. Only if you find the element, if you find the value, then no need to compare once again. So that is the best case. Within one comparison, normally say within one comparison, or is a less comparison. If you got the result, means then that is known as best case. Next is average case. Here example we can take 3. Whenever element is 3, we have to search element 3. First you should compare, not equal to 3. 3 is compared with the 2 is not equal to 3. 3 is compared with 3. So here it uses 3 comparisons. Normally middle for a total comparisons are 5. Total here required 5 comparisons. In that if you got 3 or 4 or 2, that is actually known as average case. That is actually known as average case. The last is the worst case. Worst case means what? Whenever if you want to find the element, 5. So you should first compare the 1, next you should compare the 2, next compare the 3, next compare the 4, and finally you should compare the 5. So all the comparisons are required. Whenever one comparison 1 minute is just think that one comparison 1 second is required. So here it takes more time to compare or more time to execute. That is actually known as worst case. That is actually known as worst case. Best case means only one comparison. Whenever only one comparison is there means that is actually known as best case. Whenever the maximum number of comparison is there means that is known as worst case. Remember, best case and worst case. In between that if you got any comparisons, that is actually known as average cases. Normally, if you take the algorithm, if you go to the best case, that is the best algorithm. If you can say that one algorithm is best because that should get the best cases. Best cases means within one or two comparisons. Normally you can say within one comparison or within no need to execute all the program. Executing within 2 lines, you should get the output means that algorithms are known as best algorithms. Best algorithm here. Analysis, there are 3 cases to get output. One is best case, average case and worst case. Best case means less number of comparisons and worst case means maximum number of comparisons. Normally here there are 5 comparisons are possible. I don't say only in this case 5 I told, only 5 comparisons are possible. Minimum comparison is 1. Minimum comparison means that is only 1. Maximum comparison means that is 5. So whenever minimum comparison is there means that is best case. Whenever maximum comparison is there means that is known as worst case. In between that, if you got 3, 2, 4 comparison means that cases are known as average case. That is known as average case. So we will get output analysis based on best case, worst case and also the average cases. Then how we can select the best algorithm? How we can select the best algorithm? A best algorithm should take best case normally. Should take the best case and also a best algorithm uses less time and less space to execute. For example, if you take any algorithm, if the particular algorithm takes less memory to save and execute, and also it takes the less time. For example, 1 minute and 1 second. One software is executed in 1 second, one more software is takes 1 minute. Which one is say best? 1 second. Which one executed in less time? That is actually we can say best software. Which takes 1 minute, that we can say the worst case. So what is that we can say? Not best algorithm. So that algorithms are known as time-space trade-off. Time-space trade-off. What is a time-space trade-off? That is the best algorithm. The best algorithm uses less time and less space to execute. Whenever if you are going to execute any algorithm, you should take the less space and also with the less time. Less space and also with the less time. That is actually known as best algorithms. That is known as time-space trade-off. Normally, practically if you are going to apply this one, is not possible. Because less memory, less space is there means that is the shortest algorithm. Short algorithm will be there. That one is easily to execute. But if you get into complex programs or big program, if you want to prepare on software, the algorithm is not stopping with 1 or 2 lines. It will take 100, 200 lines. Algorithms will be there. Then whenever 200 lines of algorithm is there means it should take the more memory. And it should take more time to execute. It should take the more time to execute. Not in minutes, it will take the seconds. 1 second, 2 seconds it will take. So then we can say that is ideal cases. It's not possible always, but some cases this is possible. Not all the cases, in some cases this method is applicable. Some algorithm will take less time and less space to execute. That is actually known as time-space trade-off. But if you are going to execute the programs like this, whenever if you are going to execute the program like this, or if you are going to create the softwares, but if you want to create the software, there are different steps we told already. We are using the different steps. What are different steps? First, problem analysis, problem definition, problem analysis. After analysis, design a solution. After designing, then coding, then testing and maintenance. These are the different steps are there. But normally, if you are going to execute any software, any programs, that is, in case of you are going to develop the software. Whenever if you are going to develop the software, we have to use all these steps. But in some cases, in some small programs and all, we are no need to use that one. But in that cases, we use the stepwise refinement process. We will not apply the entire problem solving method, but in that which is required for us, that we will use and we are going to find the output. And that is actually known as stepwise refinement process. The stepwise refinement process mainly uses 3 levels. Stepwise, that you can see here, stepwise refinement process mainly uses 3 levels. The first level is known as informal algorithm. The first level is known as informal algorithm. The next step is known as pseudocode. P-S-E-U-D-O. Pseudocode. Known as pseudocode. After that, we have to write the C++ program. First informal algorithm, then pseudocode, and also it will finally C or C. Not C or C program. We can use any kind of program. We can use any kind of program to execute. So this is the very 3 steps are enough. The first informal algorithm. What is the informal algorithm? That informal algorithm can be developed by using the mathematical formulas. Mathematical model means mathematical formulas. We are writing the informal algorithm. That is not contain particular steps. If you take the informal algorithm, that informal algorithm does not contain the steps. They mainly contains, for example, if you want to find the area of circle. What is the area of circle? How you can find? We will take normally algorithm is step 0. First step 1 is start, next input, next process, then after that output, finally we will get the stop. That is the algorithm. But informal algorithm is not like that. If you want to find the area of circle, which is the formula? It's a pi r. Pi r square is the algorithm. Pi r square is the value. So you can write the, in case of informal algorithm, directly you can write this 3.14 into r into r. That is, we know that area. If you wrote like that, then we can say that is informal algorithm. So just by using mathematical formulas, just we are writing. By using the mathematical formulas, just we are writing the like algorithm steps. Means which no steps are required. We know that. That is not in order sometimes. That is not to use order for that one. How you want or how you can understand. PV means who developed the program. That is software engineer. Who developed the program, developing the program. That person, he will write these some methods. You can use this one method. You will write the algorithm like this. See, for I want to develop the program is I want only this much. If I want to have the developer means I want only this much. If some other developers are there means they want some extra steps. That is actually known as informal algorithm. That is known as informal. For example, if you want to find the area of circle, pi r square is required. Area of triangle, half into L into L. Like that we can use. We know that one. What is the area of rectangle? What is the area of rectangle? That is L into B. So like that we can take. So just we should know that one. Sometimes you can write down, sometimes you can know that one. Then by using that we can write. It's an informal algorithm. After informal algorithm, the next step, after by using this informal algorithm, you should go for next step. You should go for next step. In next step, you have to develop the pseudocode. Next step, we have to develop the pseudocode. Pseudocode means, so here I wrote pseudocode. It's a narrative description of the flow of logic. Or flow logic. It's a narrative description of the flow logic of the intended program. So after this one, we are finally what we are writing. After by using this mathematical model, we are writing the programs. We have to write particular. By using that mathematical model, we should write the program. The intended program will be there. We have to write this program. For that, we have to write the narrative descriptions. We have to write narrative description. Our own method with the flow logic. How step should be first step this one, next step this one. In our own method. In our own method, we are writing. This is not an algorithm. Pseudocode is not an algorithm. It's a narrative description of the flow logic. How control will flow, how data will flow in one after another, the next step, next step, next step, next step. How data is flowing. So that we are going to write this pseudocode by using the formal language. Formal language, English. No need to use some other methods and all. No need to use the steps also. Directly English only can write. First, you have to take to input. Then next after that input you have to add, you apply the formula. Then after applying the formula, next you have to find the output. And output should be displayed to the user. So like that we are writing. Like that we are writing in the description format. In the description format, step by step, points. One point, next point, next point, next point, like that we have to write. That is actually known as pseudocode by using the formal language. After writing the pseudocode, next we have to convert that pseudocode into programs. Based on the programming language syntax. Based on the programming language syntax. Here I use C or C++ program. It's not only C or C++. If you wrote one algorithm, it's possible to write in different kind of programming languages. It's possible to convert in different kind of programming language. One program, not only one program, different program languages we can use, and it's possible to convert into different programming languages. That is, here I given as a program. After that, pseudocode, if you have to convert that to C++ or C program here I wrote, that not only C is possible to write in different programming languages. If you want to write a C or C++ program, then we require the data structures. Data structure means how data is arranged, how data should be flowed. So that is actually known as data structures. How data will be organized, how we can organize the data. That is we are going to discuss in data structures. That is not important this year. This year we are going to discuss that data structures next year. In the second PUC we are going to discuss detail about data structures. So I am not going to explain what is the data structure. By this you understand that by using the data structures, we are going to write C or C++ programs. So this is the mainly 3 steps of stepwise refinement process. The first one is informal algorithm. By using the method, we can write like this. By using mathematical model, we are going to write the informal algorithm. After that, next step, we have to write the pseudocode by using the formal language. By using the formal language, we are going to write the pseudocode. After that, we convert that pseudocode into C++ program by the help of data structures. These are the mainly 3 steps of stepwise refinement process. So stepwise refinement process mainly contains 3 steps. But if you are going to develop any software, so we are not applying this one. Whenever you are going to develop the software, we are not using these steps. Instead of that, we are using the 4 steps. One is problem definition, analysis, design and solution, then coding. After that, testing, debugging, maintenance, and documentation. That steps are there. That we are not using. Whenever small programs are there, means this is the best case. We can use stepwise refinement process. By here, we reach the end of session today. In this session, we mainly discussed about analysis of algorithm and also the stepwise refinement process. Analysis algorithm is maybe if you want to reach a particular solution. If you want to reach a particular solution, there are more than one approaches are available. More than one approaches are available, or more than one algorithms are there. Then you have to select. Choice of particular algorithm depends on the performance analysis and also the measurement. There are some measurements also there, and also based on some performance analysis, you can select the algorithm which is suitable for our program. There are different algorithms are available. You can write different algorithm. One person can write by his own method, he can write his algorithm. One more student he can write its own algorithm. There are different algorithms are available. So selecting the which one is best. That is based on the performance analysis and also the measurements. Then if you take the measurement, there are mainly 2 measurements are available. One is time complexity, one more is space complexity. Time complexity means the algorithm takes time. If you want to execute an algorithm, some time is required. That time is known as time complexity. Whenever if you want to execute algorithm, space is required. That space also known as space complexity. That is the mainly 2 measurements, one is time and space. And after that, we can analyze the algorithm by it. If you analyze the algorithm, we will get the 3 output. Either you will get the best case, average case, or worst case. Whenever output, if you got in single comparisons, less comparisons, then that is known as best case. And whenever is execute all the statement output means that is known as worst case. Gives us average number of statements means that is known as average case. Then if you take ideal algorithm or best algorithm, a best algorithm always uses less time and less space to execute the program. Whenever algorithm is here means that algorithm which always takes less time and less space to execute means that algorithm is known as best algorithm. After that, we discuss with the stepwise refinement process. Then stepwise refinement process, there are mainly 3 levels are there. The first one is informal algorithm, pseudocode, and C or C++ program. First you have to write informal algorithm by using the mathematical model. Normally what you have to write in formulas, that by using that formulas you have to write the informal algorithm. So under algorithm, steps are not required, directly we can write. After that you have to go for the next step, that is pseudocode. Pseudocode means it's a narrative description of flow logic. It's a narrative description of a flow logic. When a flow logic is there means you have to write. If you want to add 2 numbers means you have to first take the 2 inputs. After that you have to add 2 numbers, then you have to display the output. Like that, step by step, you have to write in a narrative format. After that, if you want to write that one, we can use a formal language. Any languages we can use. Then after that, finally we are going to convert that pseudocode into C or C++ program by the help of data structures. So that is, this is what we discussed in this session. By here, I will wind up my today's session. Thank you.